The topic is finding absolute extrema of functions of two variables. So let's read the definition. To find the absolute max and min values of a continuous function f on a closed bounded set D, first we need to find the values of f at the critical point of f in D, and then two, find the extreme values of f on the boundary of D, and then 3, the largest of those values from 1 and 2 is the absolute max, and the smallest is the absolute min. Alright, so let's do this example. Find the absolute maximum and minimum values of f on the set D. D is the triangular region with vertices 3, 3, so let's call this 3, 3, and then 3, negative 3, so we need negative 3, and negative 3, negative 3. Alright, so let me do the points. So this is 1, so I'm going from 3, 3 to negative 3, negative 3. And then we need 3, negative 3, which is right here. So here's our triangular region. Here are the points. Alright, and then our function f of xy happens to be x squared plus y squared minus 4xy. So again, we'll start with 1. Find the values of f at critical points, and to find the critical points we need to set fx equals 0 and f sub y equals 0 and solve for x and y. Partial derivative with respect to x is going to be equal 2x minus 4y, and the partial derivative with respect to y will be equal 2y minus 4x. So we want to set both of these partial derivative equal to 0 and solve for x. So how do we do that? This equation tells us that, how do we solve it? Should we, doesn't matter, let's solve for x or y. So y, let's solve for y. Minus 4y is equal minus 2x, which means y is going to be equal negative 2x over negative 4, so that would be 1 over 2x. Right, so that's from equation 1. Substitute into equation that has sub of y equals 0. What do we get? 2 times, I'm going to plug 1 over 2x into y, 2 times 1 over 2x minus 4x equals 0. Still goes with this. X minus 4x is going to give us minus 3x equals 0. So therefore x equals 0. Now x equals 0, plug it back here, it's going to give us y equals 0. So our critical point is, we have only one critical point, right? So what do we need to do? Step 1 said evaluate at a critical point, evaluate the function. So we need f of 0, 0. We're going to do this last. Alright, now next step, what do we do? The easiest way is to evaluate at the corner point, these points. This point happens to be what? 3, 3. This point will be 3, negative 3, and then this point will be negative 3, negative 3. So we need to evaluate the function at all these points. F of 3, 3, f of 3, negative 3, and then f of negative 3, negative 3. Alright, now what's next? Now number 2, so we need to find the extreme values of f on the boundary of D. So let's call this boundary from here to here L1, this one will be L2, and this one will be L3. So on the boundary L1, so we need to know the equation of the boundary L1. So on L1, y is going to be equal -3. So the equation is y equal -3. And then x is between -3 and 3. And I'm not including them because I took care of those corner points here. So we need to evaluate the function along this boundary. So z will be f of x vary, and then y is equal -3, which is equal to, now I need to plug -3 into each y. So this will be equal x squared plus -3 squared minus 4x times -3. So my z is going to be equal what? X squared plus 12x plus 9. Right? And then I need to calculate the derivative with respect dz with respect to x to see if there is any critical numbers. Now this is going to be equal to 2x plus 12. Set it equal to 0. My critical number will be -12 over 2, which is -6. So the point will be x equal -6. My y is going to be equal -3. So I'll go back here and I need to evaluate f of -6, -3. Alright, on the boundary L2, what would be the equation of the boundary L2? I know x is equal 3, and I know my y is between -3 and 3. So I need to evaluate the function along this boundary. So my z will be equal f, my x is 3, the y vary. So I'm going to plug x equal 3 into my function and keep the y. So that would be equal to 3 squared plus y squared minus 4 times 3 times y. So my z will be equal y squared minus 12y plus 9. Now again I'm gonna find dz dy, which is equal to 2y minus 12. Set it equal to 0. That gives me y equal 12 over 2, 6. I know my x is 3, so my point is 3, 6. So I need to evaluate the function at 3, 6. Alright, now we need to see the function along L3. L3, the equation of L3, it's a line. I know 2 points. One of them is -3, -3. The other one is 3, 3. So let me do it here. Along the boundary L3, I need to find the equation of the boundary. I have 2 points, -3. I could also use 0, 0, it doesn't matter. -3, -3, and 3, 3. So equation of a line will be what? Y minus y1 is equal mx minus x1. I need to find the slope. my slope is y2 minus y1 over x2 minus x1. So 3 minus negative 3 over 3 minus negative 3, that would be 6 over 6, which is 1. So I'm gonna say, I'm calling this x1, y1, I'm calling this point x2, y2. So y minus y1 is equal slope, which is 1, x minus x1. So this will be y plus 3 will be equal x plus 3, which means y is equal x plus 3 minus 3 is y equal x. So I know my y equal x. So the equation of the boundary L3 is y equal x, and x is between negative 3 and 3. Now let me rewrite the function here because we're going to need it. F of xy is equal x squared plus y squared minus 4xy. Now what do? I need to find z. So I'm going to plug x for each y. So I'm going to plug x here, I'm going to plug x there. So z will be equal x squared plus x squared minus 4 times x times another x. This is, by the way, f of x stays and the other x become, f of xx. So z will be equal 2x squared minus 4x squared would be equal negative 2x squared. Now I have to do dz dx, which is going to be negative 4x, which is equal 0, means x is equal 0. And then once x equals 0, we know y equal x, so therefore y is also 0, so 0, 0. But we already got f of 0, 0, so we don't need to add that number. Alright, so now last step, all we need to do is evaluate our function at those critical points. So f of 0, 0 will be 0 squared plus 0 squared minus 4 times 0 times 0, which is just 0. Right? For same thing, f of 3, 3 will be equal to 3 squared plus 3 squared, right? Minus 4 times 3, 3. And that's 18 minus 36, which is negative 18. F of 3, negative 3 will be 3 squared plus negative 3 squared minus 4 times 3 times negative 3. And that's supposed to be 54. Anyway, same way, I'm not going to plug everything in there. So f of negative 3, it's going to be negative 18. You know how to plug. Just plug it in. F of negative 6, negative 3 will be negative 27. And then f of 3, 6 will be also negative 27. So the largest one will be our absolute max. So this is our absolute maximum value, and it happens only at the point 3, negative 3. And our absolute min is negative 27. But it happens at 2 points, 3, 6 and negative 6, negative 3. And that's it.